Okay, well, this video is going to be a little bit different from the content that I normally provide, but I hope you'll find it interesting, nevertheless. Many years ago, I used to work on an airbase, and we had excellent fire safety training. Once a year, we'd all troop over to the fire station, and we'd have a lecture from the firemen, which was very interesting and informative. And then we'd troop outside, and we'd actually get to play with some real fire extinguishers, putting out some fires, which was well cool. Anyway, one of the things I remember from this fire training was that they drummed into us was the fire triangle, which I shall zoom in on at the back there. And basically that is that you need three things to create fire: oxygen, a heat source, and fuel. And if you've got those things, then you can pretty much make fire anywhere. If you have fuel and an oxidizer, and such that the fuel gives off oxygen as it burns, you can even have fire underwater. Now, I'm sure everyone's seen video of divers using flares underwater and thermic lances. Now, I believe that the flares use magnesium and the lances use thermite, and both of which, they provide their own oxygen, which is why they're able to burn underwater. Well, it turns out that there's a very common and very cheap item which anyone can buy, which also contains fuel and an oxidizer, all mixed in one, and that is, I will show you exactly what that is. The bog standard common or garden sparkler. Let's pull one of those out. Yes, one of these things. Every kid's had one of these on fireworks night. Now, I did a bit of research into sparklers, and they're quite interesting. Generally, they use charcoal and sulfur as the fuel, and they use potassium nitrate as an oxidizer, and then some sort of binder to glue it all together, which is either starch or a sugar-based substance. And then there's a metal powder in there which provides the sparks. And depending on what kind of metal that you have, depends upon what kind of sparks you get. So, that being said, a sparkler should burn underwater because it provides its own oxygen. So let's see if that's true, shall we? There we go. And no, it doesn't. Goes out straight away. Which is not entirely surprising, I suppose. I think basically what happens is that the water extinguishes the heat source before the oxidizer can produce enough oxygen to keep it alight. But with a slight modification, we can change this. This is common or garden sellotape, as you can see by the writing on the inside of the reel. And what I'm going to do is I'm going to take one of these sparklers and I'm going to wrap it in sellotape, leaving about a centimetre clear at one end to actually get it going. And then we're going to do the same experiment again and see what happens. Right, this sparkler has been wrapped in sellotape, as you can see. I've left a small amount at the end here so we can get the thing started. And then we're going to put it in the water and see what it does. I'm going to zoom in on the glass so that you can see a bit more clearly. Right. Well, that wasn't very successful. Let's try again. There you go. Flame underwater. Isn't that amazing? Now, it took a few goes, but we got there in the end. I'll try some more. Okay, I thought we'd up the ante a little bit this time, so I've got 2 sparklers wrapped. See what happens, shall we? Now that's much better. Well, for the amount of time that it ran for, yeah. Okay, clean water and 2 sparklers with a very thin covering of masking tape. So we'll try that. I'm going to zoom in initially onto the glass because it's easier, assuming it actually works. We want to see what's going on. So let's go with this, shall we? Oh, that's quite good. That one is actually very good. Best result yet. So the masking tape doesn't burn. The flame is trapped within the masking tape, which is quite fascinating. So there you go. Definitely, it's a strange phenomenon, but no, I think we'll do one more with the sellotape because you get more flame with the sellotape. Well, just before we wrap up the fire underwater experiment, I suddenly remembered that upstairs I had some conventional white masking tape, which is somewhat thinner than the blue masking tape that I was using on these. So I thought, well, we'll give that a go. Why not? You know, it's worth a try, and it might have a slightly different effect. So here we go with the white masking tape. Now, a very similar effect to the blue. I mean, it seems to burn inside the tape rather than the tape actually burning. We'll get it going again. Yeah, if anything, it's not actually quite as good as the blue. One last go, I think. Okay, well, I think that'll be it for the fire underwater experiment. It was interesting. Some surprising effects. I didn't expect it to burn inside the masking tape, which was, quite unusual. However, I think that will do, and I hope you found this little fire underwater experiment interesting. Thanks very much for watching. Cheers.